In the centuries around 1900, a great number of Danish megalithic graves was investigated and restored for two reasons. The main reason was to collect objects to put into the exhibitions in the new museums. The other reason, or perhaps rather a side effect, was to make the monuments accessible to the public. But by the public access to the megalithic monuments, we have a price to pay. Maintenance and restoration is important to secure the archaeological heritage and the visitors. And it has been a tradition to do that to varying degrees for over a century. With my colleagues Svend Ilum Hansen and Jørgen Westphal, I have been a part of this tradition for more than 25 years. Our method of combined investigation and restoration has yielded important new information, especially with respect to the construction and architecture of passage graves. And the restoration has sometimes developed into a form of experimental archaeology. The restoration practice is always to discussion, but today I will concentrate my paper on the construction and architecture of megaliths. On the background of our observations, I will try to illustrate the megalithic building process from the very beginning to the end and beyond. But I will only be dealing with the TRB builders, even to the life of the megaliths beyond belong the radical changes from late Neolithic and Bronze Age. And I do this in order to adapt the architecture and the monumentality to completely new times and beliefs. This topic of late Neolithic and Bronze Age deserves a paper for itself. Today, I will refer to observations in Danish megaliths in order to illustrate the challenges and technical demands in the megalithic building process. But megalithic tombs are not equal. Some are small or simple, and some are complicated or huge. And most of them are an average between extremes. But common to all of them is that the big stones are glacial moraine blocks, formed by the nature because bedrock is not accessible in the Danish landscape. In my opinion, this has been an extra challenge to the builders. It is obvious that the design on the whole has been adopted from the start of the construction process. In the master plan, it was necessary at the preparatory stage to decide the overall structure, for example, a single passage grave or a twin passage grave, and next to designate some of the characteristic stones to be incorporated. In our perspective today, it is fascinating how the capstones and some of the orthostats in the passage grave are utilized to the utmost and how they supply each other. The passage grave, Revehøj, here on the picture, is an illustration of this. The chamber is 2.3 meter high with 3 intermediate layers on the orthostats in a corbelled structure. The capstones are lying on the upper intermediary layer with only a small overlap. In fact, they are significantly shorter than the width of the chamber at floor level. This construction is only possible if you in advance have made a detailed planning with designated capstones, their length, shape, and individual and relative position. Not until knowing the character of roof layer, the builders were able to make the ground plan in details. Perhaps the shape was decided ahead because this is to a certain degree a regional feature, but the width and the inclination of the orthostats were depending on the size of the capstones. The capstones and the orthostats were in an important interaction if the builders had special architectural requirements to the orthostats in the walls, for example, symmetry or twin stones. Furthermore, it was important to choose the right stones as cornerstones where the passage meets the chamber. This part of the construction is the weak point and includes a keystone, which both is a capstone and a wallstone. These are examples of decisions which had to be taken before the construction process started physically. These overall features were important to know before the building site was established and the obtaining of materials took start. When first started the building process, you were committed to go for the main idea and were not able to improvise on the overall level. The initial phase of the construction itself was establishing the building site. We may imagine that the most important materials, such as the wallstones and capstone, were transported to the site in advance. The ground plan had to be allocated in the terrain. Especially the direction of the passage seems to be important. In the passage grave King Svend's Mound, we found a line of small stones on the bottom of the mound just behind two orthostats, under the packing behind the later drywalling. This line is flush with one of the walls of the passage. Therefore, this may be a line of sight in use during the initial phase of the construction. The chamber area was prepared by removing the topsoil, which was used as the first step of the mound building. We found the removed topsoil as a flat heap in the bottom of the mound, but upon the intact topsoil. Before erecting the wall stones of the chamber, some features had to be taken into account. One, how is the transition passage chamber going to be constructed? And two, may we have a closing stone? Both questions are essential to answer before deciding the final design of the ground plane. There are different technical architectural solutions of the transition passage chamber. Some solutions include the inner part, this means the first pair of orthostats, of the passage. Some do not, and Jørgen Westphal will tell you more about this. The closing stone is an important feature already in the ground plane and especially later in the process, because you make a kind of blind spot in the construction without a sustaining effect. In return, you get in many ways a shortcut in the building process. This closing stone is a common occurrence in the Danish passage graves. This stone at one end of the chamber is not load-bearing, and it is much smaller and was put in place from the reverse at the end of the building process. The existence of a kind of access path during this stage in the construction was, for example, observed during investigations into the Birkehøj passage grave. There was a channel through the mound surrounding the chamber, and we may presume that the access was possible while capstones were put on top of the chamber. When erecting the orthostats are normally standing in holes in shape and depth adapted for each stone individually. This means that the final height of an orthostat in the construction was known already on this stage. In some structures, the orthostats stand as monoliths, and in some they stand in contact to each other, often leaning against each other. A main element in the architectural expression is already created on this stage, because the size and the shape of special sets of stones with characteristics as twin stones, symmetry, color, etc., will have implications for the way forward. The architectural demands had to be combined with the technical demands relative to the capstones. When orthostats were erected, it was necessary to decide if this structure should have a ditch for drainage. If so, a small ditch filled with crushed flint was established around the chamber just behind the orthostats. It was necessary to do so at this stage because the packings of crushed flint behind the drywallings, which are the next stage of building, had to be in contact with this drainage ditch. Without building the drywallings, the tombs had never been completely sealed. The gaps between the orthostats, often a very irregular shape, were closed with a dense packing of flat stone flags, generally sandstone, laid course after course like bricks in a modern wall. The term drywalling is, however, misleading because either clay, chalk mass, or birch bark was employed between the flags. When birch bark was used, a piece of folded birch bark with the fold facing in towards the chamber was placed between the flagstones. And this drywalling is, according to Luc's paper yesterday, both filling and facade. Parallel with the building of the drywalling, it was at the back side secured with flint packing, and the flint packing was secured with mound fill, stones, earth, or both of them. This process took place step by step, some curses of flags, some flint, some mound fill, and again some curses, etc. The builder was working behind the orthostats when he formed the flags, placed the birch bark or the mortar, and the crushed flint. Investigating the packings, we find the debris from the flagstones, the splinters from the flint, and sometimes a hammerstone. The bark was an effective sealant between the drywallings, the flagstones, performing an equivalent function to that of clay or chalk mass. The bark also absorbed the enormous pressure which the capstones applied through the drywalling, which could cause the flagstones to crack. It should also be remembered that a completely different effect, color-wise, was created by the stripes of the white bark in conjunction with the orange of the freshly broken edges of the drywalling's flagstones. And to sum up, at this stage, the orthostats of the chamber and the inner part of the passage are erected. The drywalling between them are established, and the packing behind them and the core mount filling to fix the packing material is established. Perhaps there is an opening in one end of the gables where the closing stone later will be mounted. The tops of the orthostats might be regulated partially at the erection by the depth of the holes, but the substrate for the capstones has to be prepared anyway. In some regions, the capstones are put directly on the top level of the orthostat, and in other regions, the height of the chamber is increased by laying 1 to 3 layers of intermediate stones. These intermediate layers are an element in the corbel construction. The intermediate layers are secured with a flint packing and mound filling, which is incorporated in the drainage system. We have a little evidence that birch bark was used in the intermediate layers. Well, we cannot postpone to the most fascinating question, laying on the capstones. As mentioned in the beginning of my paper, we presume that the capstones were selected in advance and the relative and individual positions were planned. But how were they transported up to roof level? And how were they placed on an unstable intermediate layer without disturbing the supporting structure? Different solutions are suggested and probably different methods are used. At this stage of the building process, a working platform was established on the contemporary top level of the mound filling, in same level as the top of the intermediate layer. We have seen that this platform, as you see on the photo, was enhanced with a sort of pavement, and the top of the layer was prepared and adjusted with flagstones as basis for the capstones. A trace of ramp was found inside the mound filling, as a thin layer from the working platform sloping downwards to the surrounding terrain. 4 post holes have been found inside 4 surrounding megalithic mounds. 3 of the posts have been standing in the surface under the mound, very close to the back of orthostats in 3 monuments like this one. And in 1 monument, a post had been standing in the intermediate layer. All of the posts were removed before the tombs were completed. The post standing on the intermediate layer and one of the others seem to have been tilted forwards and backwards in the same direction as the chamber's longitudinal direction. After the posts were removed, the post holes were carefully sealed. We cannot exclude that the trace of the tilting is caused by the removing, but it does not seem probable. These observations can give us some ideas of the methods used at the process of putting on the capstones, but we do not have the answer on the question. Tumbling with capstones yourself, you cannot avoid a wondering and fascination of how these moraine blocks were controlled and handled 2 meters above terrain on a limited loose ground. And sometimes accidents occurred. We have evidence in at least 2 tombs where the capstone has fallen to a lower position than expected. One of them is this one, where the crack on the orthostat and the drywalling repaired from inside is the visible marks from the accident. To me, it is remarkable that the capstones were not adjusted but kept their position. And I don't think that the reason for this was the builder's inability. With the capstones placed in position, secured and tightened, the mound fill was supplied. A cairn of the mound is built in parallel with the erection of the orthostats and the intermediate layer, and the packing behind them. This is the starting point for completing the mound. And here on the photos at left, we see some ring stones in the mound filling. Inside the covering mound, there might be different sorts of roofs or flagstones or layers of clay as elements of the drainage system to keep the chamber and passage tight and dry. Over the capstones and incorporated within the earthen mound, there was a roof-like construction comprised of stone flags secured in a chalk mass together with large quantities of crushed flint. We don't know much about the final mound building, but it seems that the method of completing the surrounding mound depends on the character of the mound fill, which consists of stones, clay, sand, or a combination. At the same stage of the process, the closing stone was put in place and the floor was established. The curbstones were erected and the drywallings between them built up. Finally, the terrain around the monument was regulated. In few cases, we have evidence for drastic earthworks in the order to accentuate the monument in the landscape. I have chosen to skip lightly over this later part of the process in order to spend time on other aspects of the building process, because so far it has been a very technical description and explanation of building a passage grave, and I doubt if Neolithic man would be able to recognize this description so far. Constructing megaliths is largely a technical achievement, but I don't think that this was the main purpose to the builders. The technical execution of constructing the megalith was only one part of the project. The other parts were the social, religious, political, and strategic purposes. Building a megalithic structure strengthens the links between the participating people or societies. A twin passage grave might be the physical expression of an alliance. And the participating persons have a common history from the building process to be told in generations. A lot of details are not visible inside the structure, but the builders are aware of them, and they may remember particularly complicated situations, the accidents, the feast and the festivals, and other events during the building process, a basis for a lot of myths. To the common memory belongs the architecture of the chamber. Presumably only few persons know them from inside. No tombs are equal. A lot of different details characterize every tomb. Normally, the materials in the building are very local, and therefore it is tempting to believe that the architecture of the chamber reflects the surrounding landscape, which in a way has been confidential and a part of the home for the inhabitants. You could say that the landscape is transformed into the chamber. The non-technical elements in the building take various forms, but today I will mention only few examples shortly because Jørgen Westvag will tell more about these details. On the chamber floors and in front of passage grave, there are large quantities of crushed and white burnt flint. In some instances, the sides of the mounds have been more or less covered with white burnt flint. The white color seems to have a certain significance. In the passage grave Birkehøj, polishing stones and quern stones were incorporated in several places in the 11-meter-long chamber, either at the junctions between the capstones at the support points or in the drywalling construction. Sometimes one of the capstones extends a little lower into the chamber than the others, separating a part of the room. It had also become apparent that the left side of most passage graves either consists of larger or more regularly shaped stones, or is generally better or more harmoniously constructed, equal to the passage grave where the left chamber is the main chamber. The closing stone might have had a non-functional element as well. At a certain stage in the building process, the passage might have changed from profane status into a sacred one. The passage is an important element in the structure and the idea behind it, so perhaps not everybody was allowed to use it. Another feature is the duality or twin phenomenon as pair of stones, twin chambers and twin tombs. And Jørgen Westvag will tell more about this. So far, I have not mentioned the megalith's life beyond the erection of the monument by the TRB people. The buildings might be repaired and changed already in TRB. We have seen a dolmen transformed into a passage grave and some hints on maintenance. Furthermore, the regular use has changed the appearance and expression of the structures. Rituals, sacrifices, and events in connection with openings of the tomb have changed the user's impression and view on the monument, especially when several generations have used the tomb to worshipping the ancestors. Therefore, it is obvious that changes of some kind by the TR people have taken place. From an anthropological point of view, it is normal that the users have to act and allocate their own marks on the structure in order to maintain their confidential relation to the monument. You have to clean out the previous users even when they are your ancestors. In our limited investigations in the listed monuments, we have not observed such changes which with certainty are made by TRB people. But Niels Andersen's investigation of an overplowed passage grave in Damsgaard Mark are very important, and he had promised to show it. It's important because pottery dates more stages of the structure. I think that generally a building, a megalithic one as well, will not assume a final form or expression while human impact takes place. Nevertheless, it is my contention that a Danish passage grave, to a certain extent, is the result of one well-prepared, designed and implemented process, which has resulted in a monument ready for consecration and use. This process has occurred in one continuous and concentrated sequence without longer breaks. Looking at the building site and the complex and coherent elements in the building itself and the building process, I find it difficult to make another interpretation. Concerning the continuity of the building process, we have over the years been searching for traces of interruptions such as layers of washing materials, shifting sand, and layers of vegetation. We have searched for small and insignificant signs of contemporary decay inside the construction and for small amounts of material which seem to be foreign or irrelevant in the context. But no, everything is clean and straight. The flint packings from the bottom to the roof are steep, cleaned and well defined. At the foot of steep borders of mountainfield, there's no erosion. To me, it is plausible that a usable standing structure is constructed in one continuous process, followed by adjustments over time in the natural process of the user's demands. One of the themes in the discussion of building megaliths and other kinds of architecture is the question of continuity or stepwise sequences. In a contribution to this debate, it is said that the dead were incorporated not into finished buildings but into building sites. I hope that you from my presentation have a completely opposite impression of the building of Danish passage graves. And according to Chris's paper yesterday about megaliths with or without mounds, I made a contribution into 1950s. And here you see a child's answer on the question of mounds and megaliths. Thank you so much.